Hello friends. Hello friends. Welcome to our channel. In this lecture, I would like to explain another example, that is example 5. See here, design a square column 400 mm by 400 mm, 3.3 meters long, subjected to a working load of 1000 kilonewton. Use M20 grade concrete and Fe415 steel. And they also mentioned that one condition, that is the column is effectively held in position and direction at both ends. So first you observe the difference of the previous problem what we solved and this problem. So previous problem, that is in example 3 and example 4, just they mentioned that we have to design a square column. They will given the condition we have to design the square column, but they didn't mention any dimensions there. But they can given some data like axial load, all the things. Based on the data, we used a formula like pu equal to 0.4 fck ac plus 0.69 fi ac. Based on that data and assuming area of the steel equal to 1%, we used to find that size of the square column in the square and in the size of the circular column, that is like around 430 mm, like that. So here in this problem, they directly given the size of the square column like 400 mm by 400 mm. And also in the last problem, we just find out the size of the square column. For that we have to provide the area of the steel and lateral ties, all the things. But here the column size is restricted to 3.3 meters. Means in the last column just they will mention the size of the particular columns but not lengths. So just they are asking to find the size of the column and design based on that one. Okay, but here they will restricted the column size will be 3.3 meters, okay, long. So which is unsupported length here, this is unsupported length, which is denoted with L, and given the working load of 1000 kilonewtons, and we have to convert this into terms of factor also, and FCK will be equal to 20 Newton per mm square and Fi will be equal to 450 Newton per mm square. So they just mentioned you have to design a column of 400 by 400 mm, 3.3 meters long. So whenever they will given the length and particular dimensions, then you use to solve this one, whether it comes under the short column and long column. So already I explained you the terms and conditions which comes under the short column and long column. Means if L by B or L by D will be less than 12, at that time it will comes under short column, or L by D greater than 12, at that time you have solved this problem based on the long column. And here L is the unsupported length. Okay, but while solving the problem, based on the condition, you have to find out the ratio. The column is effectively held in position and restrained at both ends. Effect means you have to find out the effective length based on the given condition, which is K into L. So here L is the unsupported length and K is the constant for that particular value. And what about the conditions here? The column is effectively held in position and restrained, means they are given direction at both ends. Direction meaning here is restrained, which is fixed, and again the meaning is also called as fixed at both ends. So this is the condition which is given in the question. See here in the code book, so which was in page number 94. So there will be one tabular column for effective length of the column. So what is the meaning of the effective length? So already we people know that effective length of a column is, it is the distance of point of contraflexure, means distance between the point of zero bending moments or point of contraflexure of a buckled column. So the effective length of the column always depends upon that unsupported length. So the distance between the lateral connections and end conditions. So that is free, fixed or hinged. So what I am telling means, so the effective length always depends upon the unsupported length of the column. But if you observe here, they are given in our condition effectively held in position and direction at both ends. And direction means restraints against rotation in both ends. Means whenever the column is fixed, means automatically it will be restricted without rotation at both the ends. Like that, you have to see. And if you see any another examples which was given in another text, one more condition what I see means there will be another condition like the column has unsupported length of 3 meters and is braced against sideway, braced against sideway in both directions. So here there will be the meanings comes braced and unbraced. Braced means laterally restrained at ends. Means unbraced means laterally unrestrained at ends. Like that, opposite word. So braced meaning is laterally restrained at ends. Like that, if you see in another text means the terminology will be different. That is the reason you please see the format in what way they will just given in the question. But here the first condition is laterally restrained at both ends, or laterally direction at both ends, or laterally fixed at ends, or else laterally braced against sideway. Whenever the column will be fixed means the column will be restricted on both sides, means automatically it does not sway at in both direction. That is the condition here. Means whenever they will given braced against sideway, it the call all the things comes under only one particular type of the column. So there will be one first condition, that is 0.50L and 0.65L, where L is the unsupported length. So always use recommended value, not this theoretical value. It is better to use the recommended value. So at that condition your effective length will be equal to 0.65 times of L. And what about this 0.65 into L, which is 3.3 meters. So if you simplify, how much you will get? So after solving that one, how much you will get? So I will tell you the value. It is better to simplify in your calculators as usually. Then it will be 2.145 meters. So your effective length will be 2.145 meters according to the condition. Okay. And one more condition what we have to remember means, for braced conditions always this effective length will be less than unit value, and for unbraced conditions the column this effective length will be greater than 1. Means at that condition if there will be 3.3 meters means you will get the value of 2.145. Means whatever the value will get, so it will be lesser than the effective length will be lesser than the unsupported length. So whenever the condition which comes under the braced means which whatever the laterally restrained conditions. For example, if the condition comes under unbraced column, your effective length will be so your k value will be greater than 1. At that time you will get effective length. For example, so here the effective length value will be, so it will be multiplied by some any other value you take here 1.20. So it comes under unbraced condition. So at that time what happens means 1.20.3, how much you will get? You will get 1.20 into 3 point sorry 1.20 into 3.3. See, if you observe you will get 3.96 value. Means so your unsupported length is effective length is 3.96 and unsupported length is 3.3. So whenever the condition, so here effective length is greater than unsupported length. So whenever the condition given as braced, restrained and direction both ends, at that time your effective length will be less than the supported length. Whenever the condition based on the unbraced column, your effective length will be greater than the given condition. So you please remember always all the values, and it is better to see the conditions whatever they will given in the question. So here our condition suits the first one. So sometimes they will ask this condition also: effectively held in position at both ends, restrained against rotation at one end. So see the condition. See here whatever it suits, but you remember the first three conditions will be less than unity. So based on the bracing conditions, and the remaining three conditions, other four conditions will be greater than unity. At that time your effective length will be higher than the supported length. Then after obtaining these two, then based on the slenderness ratio we have to decide whether the column comes under the short column or long column. So first I told here itself short column or long column. So you please substitute your value. What is your real supported length will be given as 3300 mm, and the dimensions of the column is always prefer least lateral dimensions. Whether it will be rectangular means there will be different dimensions. At that time you can check whether in x direction and y direction. If it satisfies both the direction means then you can design in short columns. Okay, like that you have to check the conditions, but here there will be square column. You have to check only one side of the column, that is 3300 by 400. So how much you will get? The value will be, I will tell you that value, that is 8.25. 8.25 means your L by D ratio will be 8.25, so which is less than 12. So directly without calculation of the condition itself you will get the column in short column. And after solving this one, whether it will be braced means automatically if you check these conditions LE by D, so that is 2.145 by 400. What happens? How much you will get? You will get 5.36. 5.36 which is less than 12. Means whenever the column given as braced condition without seeing the effect effective value of the column, effective length of the column condition, then you can substitute this value. It will getting 8.25 means then directly solve the problem in short columns. Means here unsupported length value itself getting less than the ratio will be less than 12 means automatically effective length ratio you will get lesser than 12 only. Why? Because for braced condition the value is always less than unity. For unbraced condition greater than unity. That is the reason I am explaining all these conditions. So whenever the question comes like braced conditions means just check the value directly here. If it will be greater than here means then go for the condition like 0.65 times of L. Then you can check the condition. So here you will get less than 12 means you can solve it in short column. So if the condition without checking the effective length itself getting less means no need to check this value. Why? Because automatically it will get lesser value only. So that is the point what I want to mention here. Then here we will confirm that the column we have to design in short column. Okay, first condition. And again what is mentioned in the question. So here subjected to a working load. So they are mentioned that the column is subjected to a working load, and here we don't know exactly whether the column is based on the eccentrically loaded column, axially loaded column, all the things. So if you want to know that one, we have to find the condition like E minimum by D value which is less than or equal to 0.05. So we have to find out the minimum eccentricity. If the eccentricity will be based on the eccentricity, we can confirm whether the column comes under axially loaded or else eccentrically loaded columns. And again eccentrically loaded short columns there will be uniaxial and biaxial. We will discuss that things also based on the condition. Whatever the condition you will get, based on the condition you can solve that problem. So for finding this eccentricity minimum, so what is the formula here? So which was in your page number will be around 42. See here minimum eccentricity. The all columns shall be designed for minimum eccentricity equal to the unsupported length of the column by 500 plus lateral dimensions by 30 subjected to a minimum of 20 mm. So I will return this in the formula, like in the formula L by 500 plus D by 30 and subjected to a minimum of 20 mm. See here, solve this first value, that is what is L value here? Your L value is the unsupported length value, that is 3300, and D value is 400 which is given as square column. For example circular column you can take down diameter whatever it will be given, and if you simplify this value you will get 19.93. But what is given in the statement? So subjected to value of 20 mm, even though you will get the eccentricity minimum value will be 99.3, you will take that one as 20 minimum. But after solving you will get some value like 25, means you can take down eccentricity minimum at the time will be 25. Why? Because you have to take minimum as 20 mm and take maximum whatever obtained by solving the formula. But after solving you will get less than 20, means automatically you can restrict that value to 20 and take down 20 mm only. Okay, then based on this eccentricity minimum value you can check this condition, so whether your condition satisfy or not. Okay, so that is eccentricity minimum by d less than or equal to 0.05. So take down the column condition, that is eccentricity will be 20 only, divided by dimensions of the column will be 400. So simplify that one, how much you will get? So 2 times, again you will get this one also 0.05, means that one will be equal to 0.05. So here if you will get the value eccentricity minimum by d will be less than or equal to 0.05, you can design this column as short axially loaded column. Okay, not eccentrically loaded column. For example, if you will get eccentricity minimum by d will be greater than 0.05, at that time you can design short uniaxial or biaxial based on the given condition. I will explain that problems also in the further classes. Then here we will confirm that we are going to design this problem as short axially loaded column. Then our next step is take down the formula which was given in page number 71, that is pu equal to 0.4 fck ac plus 0.67 fy asc. So already in the previous problem I mentioned each and everything clearly, that is the page number of 71 is 456 2000. So it is always better to see the previous problems and come to the next this problem. So whoever watching this video directly in my channel, so they will get confused in what way I am taking all these things. So if you are coming from step by step, example 1 2 3 like that, means then you will get clear idea why I am telling all these things and in what way I am taking all these formulas. Okay, so this one will be equal to 0.4 fck ac. So already in the question they will given axial load of 1000 kilonewtons, that is P will be equal to some 1000 kilonewtons. So you can take down that as factored, which is 1.5 times of 1000 kilonewtons, which is 1500 into 10 to the power of 3 in terms of newtons. For example, after solving we get 15,000 in kilonewtons. I am converting that one into newtons, that is into 10 to the power of 3 newtons. Then in the next step, so already you will get this value, that is 1500 into 10 to the power of 3 newtons, and again 0.4 fck is 20 into area of the concrete. So already we people know that the size of the square column will be around 400 by 400 mm, which was given in the question, that is the gross area. Okay, so in this gross area only you will have AC plus AC, area of the steel and concrete. So there will be steel and concrete. So here 400 by 400 will be around equal to 1640. So this is the gross area, and area of the steel plus area of the concrete. So already there will be one unknown, so you take down any one value. So based on this you please find out the area of the steel. Here we don't require area of the concrete. Why? Because we are providing steel bars, longitudinal reinforcement. Therefore take down area of the steel outside. If you take down like this, means what happens, you will get 16,000 minus area of the concrete. Sorry, we want to take area of the steel here, therefore we want to take area of the concrete outside. Why? Because we are providing area of the steel, already I told you that one. So see here, area of the concrete will be equal to 16,000 into minus area of the steel. So based on this you will get the unknown value of the area of the steel. Then 0.67 Fy is 415, into again area of the steel. So here I am taking these two area of the steels outside. I am finding this one. So if you simplify this one, you will get area of the steel will be equal to around 814.5 mm square. So we are not finding area of the concrete here. Why? Because we are finding the main longitudinal reinforcement bars, stirrups, which was related to steel. Therefore, here I am finding area of the steel directly. In the last problems, what we used to solve this model, so just we are assuming area of the steel will be equal to 1% of the gross cross-sectional area. Then we are providing area of the steel like that. If you solve like that also, you will get the value. But so somewhat lengthy you will get and somewhat different value. So finally, whatever the reinforcement you are choosing, it will be in the same format only, like some diameter of the bars will be different, like 16 to 20 like that. So you will get some area of the steel higher if you solve like this. Why? Because we are choosing the area of the steel according to the percentage. But here if you solve like this means you will get directly area of the steel required for a particular column. So that is the only difference. So if it is not given in the question means you can solve like this. Whenever all the things will be there in the question means after solving the example, then directly solve like this. So area of the steel required will be equal to 814.5 mm square, and after that you can check whether it will be comes under minimum reinforcement or not. Actually I shown this model while solving example 3 in the square column but not shown in the circular column, so almost it will be in that limits only. So it is also same procedure, you please follow the same procedure for the circular column also, which was solved in the example 4. So this is minimum reinforcement will be 0.8% of gross cross sectional area. If you simplify that one, how much you will get? That one will be equal to, so that is 0.8 divided by 100, which is 0.008 into 400 by 400, that is around 1280 in mm square. So the minimum required area here it will be 1280. Okay, and area of the steel will be 814 mm square. So see here, so the minimum reinforcement, so the required minimum steel will be 814.5 mm square, but the minimum reinforcement what we have to provide in this column will be 1280, means the area of the steel minimum will be greater than the area of the steel required. Means we no need, we have to provide this minimum area of the steel in this particular column, that is 1280 mm square. So that is mandatory to provide this one, not this required one. Why? Because so actually it won't comes under the required. Why? Because generally the minimum reinforcement is the minimum requirement of the particular column, but after solving you will get this one as 814 mm square. But if you check the minimum reinforcement you will get 1280. So at that time we have solved this one by using 1280 mm square. So you can round off this value, and always it is better to check the minimum reinforcement. For example, if your minimum reinforcement will be 750 around means, then at that time you can provide reinforcement for this 814 only. But here the minimum reinforcement will be 1280 means, then definitely we have to provide minimum reinforcement for that particular column. Okay, so and there is a limit for maximum reinforcement also, which is 6% of the gross cross sectional area. So the 6% of the gross cross sectional area is around the 9600 mm square. So after solving the problem, maybe you have to provide area of the steel for this one means, maybe you will get after solving you will get around 2000 2500 below only. So don't exceed this value, no problem. So we are within the limits only. And the square column, so we are solving the square column. So the minimum number of bars required for the square column is 4. Already you people know that one. And for the circular column it will be 6. So then go for the trial section, that is 4 bars of some 16 dia. How much you will get this value? 4 bars, 4 and 4, 4 into pi d square by 4, 4 cancel. So 3.14 into 16 whole square, that one will be equal to 893 mm square. So here you will getting 893.84 mm square value. And go for the next trial, like 4 bars of some 20 dia. So after solving that one, again 4 and 4 cancel, means how much you will get? 20 whole square. So which is 1256. 1256 in a mm square. Then I am checking. So this 1256 also lesser than the minimum requirement, that is 1280. Then provide 4 bars of some 25 dia. That one will be equal to 1962 mm square. 1962 mm square, around 1962.5. So if you want, you can prefer 6 bars also, no problem. Then check the trials in 6 bars also, that is 6 bars of 16 dia. How much it will take? So 6 into 10 into pi d square by 4, already we know that. 6 into 16 square by 4, so you will get 1205. It also not suits. And provide 6 bars of 20 dia. Check the trial version. 6 bars of the 20 dia, how much you will get? Maybe you will get around 1884. So if you see, almost here it will suited in the 4 bars of 25 dia or else 6 bars of 20 dia. Why? Because these two values will be higher than the area of the steel minimum. So area of the steel minimum. So then provide whatever the bars you want. So if you provide this bar, means so you can provide minimum 6 bars of 20 mm dia, and provide the spacing of the lateral ties according to the given codal provisions. Okay, here I am choosing provide 4 bars of 20 mm dia. Therefore area of the steel provided will be equal to, that one will be equal to 1962 mm square. So here the minimum area of the steel will be 1280, and provided will be 1962, and maximum will be 9600. So whatever the area of the steel we are provided, it does not exceed it to 9600. Otherwise the reinforcement will be higher on that particular column. For example, if you go for multi-story frames, at that time we have, based on the heavy load condition, we can provide some more reinforcement on that particular column, but at any cost, for this particular dimensions of the column, it does not exceed 9600. So that is the reason always you can check the limits and provide the reinforcement within the limits. Okay, then after providing the area of the steel, then your area of the steel will be 1962. After that, what we have to do? So then provide the lateral ties. So lateral ties will be same as the previous condition, lateral ties. So for lateral ties, according to the codal condition, what is your lateral tie? So what is the page number for the lateral tie? Already I explained each and everything in the last examples. Therefore, I am directly taken here. It does not be less than 4 times of the diameter of the bars what we provided, that is 20 by 4. So you will get here 5 mm 5 times. So divided by 5. So therefore, and second condition, it does not take less than 6 mm. Sorry, here we are provided 4 bars of 25 mm dia, 25 mm dia, not 4 bars of 20 mm dia. So change this value to here, and it will be around 25 by 4 will be equal to 6.25 by 4. How much you will get? 25 divided by 4. So that is 6.25. So 6.25 mm. Okay, so you please correct this value. We are providing 4 bars of 25 mm dia. So for that one you will get 6.25, means we are around of this value to the next value, which is 8 mm, and next value is does not less than 6 mm. So out of these two condition, one will be referring as 6 mm, another will be 6.25. Therefore here least value is 6.25. Therefore I am providing next best value, which is 8 mm. So minimum lateral tie will be 8 mm in our particular column, and our next one is pitch. So pitch, for pitch what are the conditions? Least lateral dimensions of the column. So here the least lateral dimensions, there will be two column sizes, one will be square column, therefore I am taking first one as 400 mm only, and the second one 16 times the diameter of the 16 times the diameter of the longitudinal bar. So dia of the longitudinal bar. So that one will be equal to 16 into 25 times. So we are providing 25 bars, that is 16 into 25 bars. That is around 400 mm only. So next step is 300 mm. So out of these three conditions, here we are providing least of the following, that is 300 mm. So therefore, we are providing lateral ties of, provide 8 mm lateral tie, 8 mm lateral tie with 300 mm pitch, means that is spacing. So this is the requirement according to our codal provisions. Then we have to draw the detailing of the reinforcement. So each and everything will be same. So the detailing of the reinforcement is also same as the previous problems. So that is the size of the square column, which is in the form of square, and again we have to provide the reinforcement, so which is according to the cover we are providing the stirrups, and here we have to provide the steel bars 4 mm, sorry, 4 bars. Okay, so already people know this is the cross section here. So generally it is around 400 by 400. So this is the 8 mm lateral tie. So there will be 4 bars of 25 dia. So if you can project this elevation, you will get like this. So I'm cutting the section. So I'm seeing the elevation somewhere. So I'm cutting this section and I'm looking here in the front side. So on the stirrups will be like this. So this is the continuation here. So this is also restricted to 3.3 meters only. So we are designing the column. So provide all the things in the required data. That is, this is a longitudinal bar of 4 bars of 25 dia. So after cutting the section, so the elevation will be in this way. Here also it will be like this. And there is a spacing of minimum 300 mm, that is pitch. So this is the longitudinal bar of, so lateral tie using of 8 mm. So this is the detailing of the reinforcement for that particular square column. So in the same way you have to design the circular column also. For example, if they don't mention any circular column of size, means in the same procedure just AG will be different. Here we are using 400 by 400. At that time we are taking just AG will be equal to pi d square by 4. There you can take down the diameter outside. So in the same way you have to solve the circular column also, but you always check the limits, eccentricity, and effective length to the column ratio, all the things in the same format only. So this is the way to solve the column. So based on the given condition, you have to check whether it will comes under the axial loaded column or uniaxial loaded column, means which is eccentrical column, and again whether it comes under the slenderness ratio. Based on the slenderness ratio, whether it will comes under the short column or long column. First check the requirements, based on that only you can design whether it will comes under short column or long column. So this is the way to design the column. So I hope you understand this lecture. If you really understand this lecture, please like this lecture, share it to your friends and subscribe our channel. Thank you so much.